Welcome back. This is Free Work Investments out here, all things electrified. So today we're going to talk about solar panel calculations. So if you remember from the last video, go check on the last video. This value, total power consumption, we calculated this value from the last video. So today we're going to calculate how amount of power to be produced by the panels which we want, and the number of panels, minimum number of panels that we can put on the system. So, as you can see, we have listed our total power consumption. Then, secondly, we have the sum of sunshine peak hours in your country. As we say, now our location is Zimbabwe, so it's 8 hours. So this is dependent on your location. So you just go and search on the internet and pin your location, and it will show up how much sunshine hours you have. So how do we calculate our power to be produced by the solar panels first? The PV power. We say PV power is equals to total power consumption. This is in watt hours, all over sum of peak hours. So for now, let's say we have 14,994 watt hours, all over 8 hours. So if you grab a calculator, the hours will cancel. Then 8 into that gives us 1,874.25 watts. So this is the power to be produced daily to counter this power consumption demand by our appliances. So now, to calculate the number of panels you require to counter this power, so you have to take an ideal panel that is available in your area. If you search, there are many panels. So for this instance, I might choose in Zimbabwe. I might use an 410 watts. 410 watts. Let me just draw an ideal panel here. This is a 410 watts power. Then this is also important to know the VOC of this panel. This is a 39.05 volts. Then the current also, the open circuit current is 10.11 amps. So, to calculate the number of panels that we need to counter this, we say this PV power divided by the power of this panel, one panel. So let's say number of panels is equals to PV power over power of one panel, which is equals to 1,874.25 What's divided by 410? We get 4.57. Approximately equal to 5. Round up 5 panels. So number of panels is equals to PV power times over power of one panel, which is 410 here. So it's 1874 that we have calculated from PV power over 410 watts. So if you divide this using your calculator, you get 4.57. But as you can see, there's no panel size half panel. So approximately this will give us, if we round off, will give us 5 panels. So this, take note this value, this number of panels, these are minimum number of panels that we might need for the system. Maybe this is just panels to meet this total power demand. But maybe for the system to really charge fully when there's days of autonomy, like there's overcast, and we might need to increase the number of panels to fully charge the battery capacity. So thank you guys for following through the calculations. Please like, share, and subscribe.